Hello everyone, Gaza Mutkash, and I welcome you all to the session on intermediate SQL queries. So guys, let's have a look at the agenda for this session. The agenda for this session includes understanding the concept of joins in SQL. So prior to understanding joins, we have to understand the concept of primary key, foreign key, how the two different tables are related. And then we'll be looking at a couple of different joins, namely inner join, left join, right join, and full outer join. So guys, prior to this session, we have discussed the basic SQL queries, including the select clause, the where clause, the filtering, the sorting, etc. So guys, let's switch to MySQL. So guys, currently we are in MySQL, right? Currently we are in MySQL. Now let's understand the data that we have. So I'm using this DB demo one. This is my database that I'll be using, and see, I'm having these two tables, and these two are related tables. So let me drop them first, and then I'll show you. So guys, these are the two tables. The first table is the employees table, right? I'll call this employee one. So let's understand the table schema. So I'm creating a table employee where the employee ID is integer, and I've set this to auto increment, and this is primary key. Auto increment means the value in the employee ID will be incremented automatically, so I don't need to pass, let's say, values for the employee ID. The second column is employee name, that is varchar. All right, I'm setting its data type as varchar 100, so I'm assuming employee name can take 100 characters. The third is the department. I'll just call it department. All right, and the department is varchar 50. Then I'm having designation, so I'll call this profile. All right, or let's call this job role. So I'm having the employee name with 100 characters. Then I'm setting department with 50 characters. Then I'm having job role with varchar of 50. Next, I'm having city with a varchar of 50. And then we have the joining date with date. The data type of joining date is date. So this is my employee one table. So let me execute this. So guys, I've created the employee one table, right? The second table that I'm creating is the projects table. So let's understand the project table, the schema for the project table. So guys, as far as the project table is concerned, over here I'm having this create table projects, and I'm having the project ID. So again, project ID, I've set this as integer. This is going to be an auto increment field, means it will be incremented automatically, so I don't need to insert values in this field. Then I'm having the primary key. Next, I'm having the primary key. All right, I'm setting this primary key, indicating that this column will be unique. There won't be any null values. Then employee ID is supposed to be integer. So the employee ID that I've passed over here, see, when we talk about projects, right, projects in the organization, so it's the employees who work in them. So this employee ID over here is an integer, and then over here I need to mention the project name, where I'm having the data type is varchar 100. I've set its data type to varchar 100. Next, we have the start date. So start date I've set as date, and the end date is also what I've set as the date, right? So then we have the status. So status over the status that we have over here is varchar 20. So this is the status of the project. So over here we have a concept of foreign key. Foreign key, we have also we have discussed that the foreign key is a constraint as far as MySQL and Postgre is concerned. So what is the foreign key? Foreign key establishes a relationship between the two tables. So foreign key, let's say, refers to the common column which is present in the both table. So over here, employee ID from the project one table, right? Employee ID from the project one table is referring to the employee ID from the employee table. So this is how we define the foreign key. So over here I've mentioned foreign key employee ID, and then references. What is the table to which it refers? So it refers to the employee one table, and what is the column to which it is referring? It is referring to the employee ID. And next, I've mentioned on delete cascade. It means that if from the parent table, if the employee ID is deleted, the corresponding let's say the employee ID, the corresponding project details for that employee would be deleted from the project table as well. This is referred to as on delete cascade. Now it's completely optional. So means if need be, I can get rid of this for the time being. So all right. So this is what I've executed. So I'm creating this projects table. Let's execute this. All right, but the salary over here is not mentioned, right? Okay. So let me add some random salary values as well. So let me drop this table again. I'll be adding the salary column. after the joining date, I need to add the salary. So salary would be integer. So these are the columns that I'm having in the employee table. I'll be adding the salary. So I've executed this. We have seen the table profile projects as well, right? So then I'm creating the table projects. Now I'll be inserting the data into the employee table. So over here I'm having employee name, department, designation, city, joining date, and then the salary. So insert into employee one. So I'm having employee name. Now this is department. So for designation, I have the column as job profile. Then we have city, then we have joining date, and then we have the salary. And what are the values that I'm inserting? The values that I'm inserting are so the first employee that I'm adding is Arjun Mehta, the department is IT, job profile is software engineer, the city is Delhi, and the joining date is 2021 4/15, and maybe the salary is let's say 85,000. Then we have Sneha Patil, the department is HR, the job profile is HR manager Noida, and over here the salary is maybe 54,000. Then Rohit Das, finance accountant Mumbai, over here the salary is somewhere around 65,000. Then for Neha Kapoor, IT QA engineer, over here the salary could be somewhere around 68,000. For Vikram Rao, it's a marketing manager, so maybe the salary is 48,000, or let's change this to 81,000. Then we have sales executive, so this is definitely 47,000. Then Amit Trivedi, IT, so that's a DevOps engineer, so maybe 72,000. And Pooja Nair, financial analyst, so maybe over here I can add financial analyst, maybe again 85,000. Then sales manager, so this could be maybe 65,000. And lastly we have HR recruiter, so this is maybe 34,000. All right, so guys, these are the details that I wish to insert into the employee tables. So let's insert them. Unknown column, job profile. Okay, so I think over here I've mentioned job role. Yeah, so this would be the job role. So let's execute this. So this has been executed, and then I'm having the project details, right? So I don't have the project details for all the employees. I'm having project details for employee ID 1 2 3 4 5 7 9 and 10, and there are a couple of null values as well. Null indicates missing values. So insert into projects one, employee ID, project name, start date, end date, status, and then the values. So status is let's say completed, ongoing, or planned. So let's execute them. So guys, clearly we have inserted the data. Now over here, if we just look into the table, select star from employee one. So these are the details that we have. And then if I were to add, select star from projects one. All right, so what are columns in the employee table? I'm having employee ID, employee name, then the department, then I'm having job role, then I'm having city, then the joining date, and then the salary. And as far as the projects is concerned, let's check this. So this is projects one table. So for the projects one table, I'm having the project ID, then the employee ID, then the project name, then I'm having start date, then the end date, then I have the status. So guys, these are the details that we have. Now suppose I want to join them. So let's understand the concept of joins. So using joins, I can display the columns from both the tables together in a single table view. That is when and where we use joins. So when we talk about joins, right? So let's say, why do we use joins? So it is used to combine multiple related tables with at least one common column. All right, using one common column, the tables would be related. So it uses the primary key and foreign key relationship. All right, primary key foreign key relationship between the common columns in general. All right, this is the general statement. It may vary depending upon the scenario. So join can also be based on multiple columns as well. Now let's proceed to types of joins. So the first type of join that we have is inner join. So what does inner join returns? It returns matching rows from both the tables, but only for the selected columns. All right, for the selected columns, it is going to return the matching rows from both the tables. So this is the table structure, right? This is the table structure that we have. So based on this table structure, let's see what all things can we join them with. So suppose I want to display, select, I want to display the employee name. So I can mention employee name. Then I want to display the job role. I want to display the city. I want to display the joining date. I want to display the salary. I want to display the start date. I want to display the end date and the project name. The project name, start date, end date, and the status. These are the columns that I wish to display, but couple of columns are from the employee table, couple of columns are from the project table. So over here I have to mention from employee 1, I'm calling it E1. E1 is the alias name that I've let's say applied to the employee. Then what is the table that I'm joining it with? So I'm joining it with the projects table. So this is my projects table and I'll call it P1. And what is the joining condition? My joining condition is the common column. So over here I'm having employee ID, and even over here I'm having the employee ID. So employee table is aliased as E1 and the projects table is aliased as P1. So over here I'll be writing E1 dot employee ID should match with P1 dot employee ID. So that is how let's say we define the join syntax. That is how we have to write the join syntax. Now because I've mentioned alias names over here, so I'll be mentioning the alias names in the select query as well, indicating the table from which we are fetching the columns. So I'm E1 dot employee name, E1 dot job role, E1 dot city, E1 dot joining date, and E1 dot salary. And this is P1 dot project name. Then we have P1 dot start date, then we have P1 dot end date, and then P1 dot status. So guys, let's run this. So inner join, when I've mentioned inner join, it is only going to return matching rows from both the tables for the selected columns. So clearly the matching rows are 1, 2, 3, then 4, 5, 7, 8, 4, 5, 7, 9, and 10, right? We don't have details for employee ID 6 and employee ID 8. So for 6 and 8, no details would be fetched. So maybe I can mention E1 dot employee ID as well. So we'll check this, that no records are fetched for 6 and 8. So this is projects 1. So guys, as you can see, I'm only fetching the details for employee ID 1, 2, 3. Then we have 4, 5, 7, and 9. All right, we have employee ID 1, 2, 3. Then we have 4, 5, 7, 9, and 10. We don't have the details for over here. We don't have the details for other employees. So these are the employee names, job role, city, joining date, salary. Then project name is fetched from the project name is fetched from the projects table, right? Then I'm having the start date, the end date, and the status. So start date, end date, status, and the project name, these columns are fetched from the project table. All right, these columns are fetched from the project table. So guys, this is the concept of inner join. It returns only the matching rows. Next we have left join. So what is left join going to do? It returns all the records from the left table and matching rows from both the tables. All right, so there's one more thing I would like to add over here. The first table that we write in the from query, that is the left table, and the table written after the join is the right table, right? So in this example, what is my left table? My left table is over here. My left table is E1, and the right table that I'm having is the right table is projects 1, right? So that is how we define the left table. Whatever table we end up writing in the from query, that is our left table, and the table that we write in the after join, that is the let's say right table. So this is the right table. So considering the same logic, what is left join going to do? It returns all the records from the left table and matching rows, or let's say matching records from both the table. All right. So this is what it does. So this is the left join. So returns all the records from left table and matching records from both the tables. So let's see this in action. So over here, what I need to write. So over here, I'm writing, let's say select even.employee ID, even.employee name, even.job role, even.city, even.joining date, even.salary. And then p1.project name, then p1.start date, p1.end date, p1.status. Now instead of inner, I'll be writing left. So left means everything will be included from the employee table. So I'll also be fetching the employee details for the employee ID 6 and let's say 10, 6 and 8. Let's run this. So guys, this is what we have. See, I'm fetching the employee details for 6 and 8, but for 6 and 8, there are no project details available. So we don't have project name, start date, end date, and status. So these values are null. All right. And as far as the right join is concerned, so it's just the opposite. So if we were to use the right join, so what is the change in the right join? In the right join, it returns all the records from the right table. So the priority is the right table. All right, and the matching records from the both the tables. This is what it is going to return. So over here I'm writing select even.employee ID, even.employee name, even.job role, even.city, even.joining date, even.salary, p1.project name. So these are the columns that I'm fetching from the employee table, and then I'm fetching p1.project name, p1.start date, p1.end date, and p1.status. So where am I fetching these from? These I'm fetching from the projects table, right? These I'm fetching from the projects table. So this is projects 1 p1, and then over here we have the employee 1 even. Employee 1 is aliased as even, and instead of left join, I shall be using the right join. Over here I have to use the right join, correct? So this is employee even right join projects p1 on even.employee id is this is matching with p1.employee id. So let's run this. So it returns everything from the right table. So everything from the right table does not include, so the right table over here is projects. Okay, I'll mention this again over here. In this example, what is my left table? Left table is employee. All right, left table is employee, and the right table that we have is projects. Even over here, my left table is employee, and what is my right table? The right table that we have over here is projects. So guys, these are the details that we have. Let's run this. So I'll be fetching everything from the right table. Now we have already seen that the projects table does not include employee details for employee ID 6 and 8, so they'll be excluded even over here. So if we check, we are fetching the details for employee ID 1, 2, 3, 4, 5, 7, 9, and 10. Only 8 rows are returned. We don't have the details for employee ID 6 and 8. All right. Why? Because in the right table, in the projects table, there were no details for employee ID 6 and 8. So this is how we use the right join. We have seen the implementation of left join. We have also seen the implementation of inner join. So besides this, we also have full join. So when we talk about full join, so how do we define this? It returns all the records from both the tables. It returns all the records from both the tables. All right. It returns all records from both the tables for the selected columns. So this has to be mentioned for the selected column because it's not going to return everything on its own, right? So we have to select the column. And even over here for the selected columns. So when this is going to return everything from both the table. So see, in MySQL does not provide return keyword, or let's say MySQL does not provide the full join keyword, right? Full outer join or full join keyword. So the approach over here varies. So how do we change this? First of all, we write with the left join, and then we, let's say, concatenate it with, or we union it with the right join. So this is my details for the left join. I'm fetching everything from the left table. All right. And next for the same, but for the employee ID 6 and 8, for employee ID 6 and 8, these details are not mentioned. Then I'll club it with everything from the right table. So this clubbing requires the union. Union is again, let's say, meant to combine two tables, but combine two similar tables. So instead of over here I've used left join, this will be my right join. So now if I run this, this is the implementation of full outer join as far as MySQL is concerned. So guys, now if we check, we do have details, right? We do have these details. We are able to fetch all the details for 1, 2, 3, 4, 5, 6, 7, 8 and 9. So this is how we can implement even full join. So guys, we have seen the implementation of the different types of joins, namely left join, right join, inner join and full outer join in MySQL. Now we'll be implementing the same in Postgre. So guys, now we are in the Postgre window. So I'm using a different set of data. Over here, I'm having the customers table and then I'm having the orders table, right? So I'll show you the data. Let's understand the table schema. So in the customers table, I'm having customer ID, which is serial, that indicates it will be auto incremented. The customer name is varchar 100. So customer name can take maximum of 100 characters. Then city is varchar 50, means city can take a maximum up to 50 characters. Then gender is character. It is only going to take a single character. Email is again varchar 100, so that is going to be unique. All right, email will be unique. So I'm executing this. This is the customer details. These are the customer details that we have. All right, so I'm having customer ID, customer name, city, gender, and email. Then we have the orders table. So for the orders table, we have the order ID, which is serial and primary key. Serial indicating that it would be auto incremented. Then customer ID is integer. Now this is going to be the foreign key because it's only a customer who will be making the order, right? So over here, the customer ID is going to be integer. And what is it referring to? It is referring to the customers table. So over here, I need to write customers one. All right. So this is the customers one table that it is referring to. And what is the column that it should refer to? It should refer to the customer ID. It would be referring to the customer ID, right? And on delete cascade again over here indicates that if the original customer's data is deleted, the same data would be deleted from the orders one table as well. So over here, I'm having order date as date. So order date, see when the customer is placing some order, so there has to be some order date, right? So what is the order date over here? It will be date. Then we have the product name. So the product name is going to be varchar. And then we have the quantity. So over here, the quantity would be integer. And then we have the total amount. So total amount is numeric, that takes up to 2 decimal places. So quantity is integer and the total amount would be numeric. So the price is not mentioned and we don't have price even over here. So guys, let's execute this. So this was the table structure. Okay, I'll have to drop the table first. Let me drop the table and then I'll be executing. So over here, I'll be dropping drop table orders one. So query returned successfully. This table has been dropped. Now I'll be dropping the customers table. So this is customers one. Yeah, and we have successfully dropped both the tables. Now I'll be creating this table from the scratch. So this is my customers table. Then I'm having the orders table. So guys, the tables have been created. Next, this is the data that I'm inserting. So in customers one, I'm only inserting customer name, city, gender, and the email values. And let's see how many records do we have. So we have inserted 10 records. So if we check the customers table now, so I can write select star from customers one. So if we check this, what is the output that I'm getting over here? My output is customer ID, customer name, city, gender, and email. All right, these are the columns that I'm having: customer ID, customer name, city, gender, and the email. Next, I'm inserting the data into the orders table. So for customer ID, I'm having customer IDs from 1 to 10. Let's see the details in the order table. So in the order table over here, I'm insert into orders. We have customer ID, order date, product name, quantity, total amount, and then values. So customer ID one has placed an order on, let's say, 0501, the laptop, and this is the price. So order for customer ID 2, order for customer ID 3, order for customer ID 4, customer ID 5, then again order from customer ID 1, 6, 7, 8, 9. So maybe we can repeat this. Even this is, let's say, customer order ID 7. So maybe this could be for order ID, let's say this could be maybe 2. All right. So these are the records that I'm inserting. So there are a couple of customer IDs that I have ignored. What are them? What are they? So over here I'm having 1, 2, 3. See, customer ID 4 has not placed an order, and then customer ID 9 and 10 have not placed an order as far as this data is concerned. So let's execute this. So guys, clearly यहाँ पे भी हमने 10 rows insert कर दिए हैं. So let's see the different examples of joins. So the concept remains same even in Postgres. So the first join that we'll be discussing is the inner join, and we already know that it returns matching records from both tables. Matching records from both tables for the selected columns. All right. So this is what we have, and let's run this. So select c.customer id comma c.customer name. So c.customer id indicates c is the alias name for the table customer 1, and customer id is the column from the customer table. Then c.customer name again indicating c is the alias for the customer table, and o is the order id for the product table, right? O over here, o is the alias name for the orders table, and order id is the column from the orders table. Then I'm having o dot product name. So o is the alias name and product name is the column from the orders table. So how am I joining? I'm let's say my over here in this example, what is my left table? The left table that we have over here is customer 1, and what is the right table? The right table that we have over here is orders 1. All right, this is my left table, this is my right table. So let's execute this. So the purpose of joins is to, let's say, display details from multiple related tables all at once into a single table. So let's see this. So guys, we are able to fetch customer ID and customer name from the customers table, and we are also fetching the order ID and the product name from the orders table. How many records are returned? We are getting 10 records. Why we are getting 10 records? Because 10 orders have been placed. 10 orders have been placed, right? So I'm over here I'm fetching 10 different records. So this is how we can implement the inner join. Next we have next I've applied left join. So as far as the left join is concerned, let's say it returns everything from the left table, and matching records from both the tables for the selected columns, of course. So how do we use it? So the query remains the same. So select c.customer id, c.customer name, o.order id, o.product name, then from customers, customer 1, c. So alias name for customers table is c, and then I've used left join. So means targeting the customer table to fetch all the details from the customer table, and then I'm joining it on orders 1 o. And what is the joining condition? c.customer id should match with o.customer id. This is what we have. So if I were to execute this, so guys, this is what I'm getting. And if you check, because we have applied left join, so how many records am I fetching? I'm fetching 13. So let me, okay, this is we are not able to sort this from here. So if you check over here, let's observe the details. So we have employee details 1, 2, 3, and then we do have 4, we have 5, we have 6, then we have 7, 8, 9, and 10. So we can even sort them, we can even order them as well. So let's see how would we do this. So guys, over here I can simply mention order by c.customer id. So this way it would be better to understand the details. So guys, now if we check, all the customer IDs are in order. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So these are all the details. Likewise, I can apply the right join. So this is the right join that we have. So everything from the right table and the matching records from both the tables for the selected columns. So the query remains entirely same. So I just need to execute this. So right table is on priority. So let's say we won't be fetching anything for customer ID 10, for customer ID 9, and there was one more. So let me order by c dot customer ID. So let's see this. So we have 1, 2, 3, 5, 6, 7, and 8. No details we are fetching for, let's say, customer ID 4 and maybe 10, 4, 9, and 10, right? Then lastly, we have the full outer join. Full outer join, so it simply returns everything from both the tables. For the selected columns. All right, this is what it is going to return. So let me run this. So guys, as we can see, this is returning 13 records. So again, I have to order it by customer ID. All right, so this is what we have. So we have customer ID, customer name, order ID, and then we have the product name. So we have 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So guys, we have successfully implemented and understood the concept of joins, and we have implemented the different types of joins as well. So that brings us to the end of this session. So guys, in this session, we have understood the concept of the foreign key, and we have implemented the corresponding, let's say, table joining condition utilizing the foreign key. We have also understood and implemented the different type of joins. So in the next session, we'll be moving forward to the concept of group by, having, and even aggregate functions. Thank you.